I love this show. Sometimes, the way that you think things will go and what you expect doesn't match reality. This is a story about unmet expectations. But don't worry, it's got a great ending. So I've been in tech for a long time. I was a software engineer at MongoDB, and then I took this short stint at O'Reilly Media, the tech publisher that puts animals on the books. So between the talks at the Velocity conference and all of the SRE materials that we were publishing, it became clear that chaos engineering wasn't just a fad. It was something that was meant for more than just Netflix and Google and these large companies. After my time at O'Reilly, I went to Datadog. And I was a technical evangelist at Datadog, and when I was there, I started to dive even deeper into chaos engineering. Datadog is a monitoring and observability platform. And chaos engineering is a fantastic way to validate your monitoring. If I inject a little bit of latency into a system, I should be able to see that in my APM tools. If I black hole a service and cut it off from the network, I better get alerts that my service has lost network connectivity. The other cool thing is when I was at Datadog, they actually started to do chaos engineering on the platform itself. Monitoring and observability is critical, and so using chaos engineering to ensure that it was a reliable service was definitely a good thing. The cool thing is my job there was largely about telling the stories of Datadog. And this meant that I got to work with the engineers at Datadog and tell the story of how we did chaos engineering. I'd travel all around and I got to share about how we planned out our game days.
Yeah, the party last night was awesome, so thanks to Google for that. Number one lesson is don't be a jerk, right? We'll talk about how to plan these, we'll talk about how to run these so that you're actually learning and being a good colleague. So at Datadog, we start with game days.
And I could tell people about the process, about how we prepared to run the game day.
Whatever you do, write down your plan B. What are you going to do if things go wrong? And then finally, most importantly, share the document.
We could talk about the methods of what we did when we were running experiments.
And then nuclear holocaust, all-out war, everything is dead. Terminate the region or the cloud. This is the ultimate goal for everything. At Datadog, we're multi-cloud, so we use a bunch of different cloud providers.
And obviously, the most important then was to learn from it.
At this point, we run anywhere from 4 to 6 game days a week. So we try to not have them overlap. So it's usually about 1 a day. So at this point, we don't email them directly all the time. Usually we bundle them up and we have a weekly report. And the most important part of the after section is you celebrate.
I got to spend a lot of time inspiring people and educating them on how to do chaos engineering in their own systems. During this time, I met the folks at Gremlin. At the time, they were probably the only company that was building a chaos engineering platform to make the practice accessible to everybody. And I thought, wow, this is incredible. So fast forward a few years. Tammy Butow, who at the time was the principal SRE at Gremlin, reached out to me. And she asked, hey, you spend a whole lot of time talking about chaos engineering. Have you ever considered joining Gremlin? So I did. As Director of Advocacy at Gremlin, I lead the team that's responsible for education. That means I get to talk to folks like you and help share information about how to do chaos engineering. But that's only part of what I do. I'm also responsible for running chaos engineering inside of Gremlin. Now, with my history of sharing how Datadog did chaos engineering, you'd think that this would be easy, right? I mean, I've literally told thousands of people how to do chaos engineering. I've stood on dozens of stages and run live demos doing chaos engineering and leading the audience through an experiment. So all of this should be pretty easy, right? Wrong. Remember, I told you this is a story about unmet expectations. Gremlin's a startup. And then when I joined, we were hiring several people every single month. Most who had only heard about chaos engineering, but never actually done it. Like every startup, the number one goal is to ship code and build the product. You hire engineers to write code. You don't hire them to do game days all the time. So of course, I took what I knew from what we'd done at Datadog, and I'd mixed it with some of how Gremlin traditionally did chaos engineering. And then I deployed it, or I rolled it out. And, well, it turns out that some people didn't like me very much, specifically our engineering managers. You see, you'll hear a lot about how to do chaos engineering, especially at conferences just like this. You'll hear talks about how to define a hypothesis, how to inject the failure, how to analyze those results to make your systems more reliable. And that's the easy part. The problem isn't that people don't know how to run experiments. We've all learned this in grade school on how to do science. The problem really is everything else. Gremlin builds a chaos engineering tool. So everybody already understood the value of investing in reliability and of doing chaos engineering, but there was still a struggle of how to prioritize that work and how to balance it with feature development. After rolling this program out and trying a few things, one engineering manager came up to me and complained that I was bringing his team to a grinding halt. Because every week for 2 hours, his team was not doing work. They were stopping and planning and doing a game day and then analyzing the results. Another engineering manager complained to me that we had generated so many tickets, so many Jira tickets from the first game day that it was enough to fill an entire sprint. And obviously that would mean derailing the work and delaying the product feature that she was working on. So if I were to sum up these complaints into 3 themes, it would be this. Number 1 is a lack of time. We want to ensure that everyone in engineering has some experience doing chaos engineering. And you should too, right? You should want everybody in the organization to care about reliability. It's not enough to have just a handful of SREs be responsible for all of it. So everybody needs to do this. But if everybody is doing chaos engineering and running game days, if they're spending an hour or 2 hours every week, that's a pretty big time commitment. The second would be a lack of process. One reason that it can take a lot of time is that the process isn't clearly defined. We see the same problem when it comes to incident response, and that teams that have well-defined processes in the form of runbooks and documentation, that they tend to solve problems much faster than teams that don't. The third theme would be a lack of priority. When game days result in tickets, and they often do, and they often result in high priority tickets, because you're discovering what can often be major risks that threaten to bring down your entire application. So when you discover these issues and you generate new tickets for it, how do you go about prioritizing? How do you include this new unplanned work into your existing sprint cycles? And how do you do so without derailing the planned work that you've already had and affecting the delivery dates that you've committed to or that you've promised to other teams or customers? So I met with our engineering director, and we came up with some solutions. In terms of time, we asked, can we make it shorter? If we can make it shorter, and if we can do it with fewer people, then maybe we can do them more frequently. And we can rotate engineers so everyone has a chance to participate over the course of a few weeks. When it comes to process, I mentioned runbooks. And there are a lot of great companies out there that have helped to automate the incident response process. Companies like Fire Hydrant or Blameless or Rundeck, and there are many of these. So I really wanted to automate as much as I could. And I mean, let's face it, I'm still an engineer at heart, so of course I wanted to automate things. The third issue was those priorities, and this was a big one. We didn't want to screw up the product timetables, and we didn't want people to just do those easy tasks, the ones that they could accomplish quickly, but we knew wouldn't make an impact or wouldn't make a significant impact on the company's reliability. So I thought about it, and I realized that we could really distill this down to one question. What's the one thing that you can do that would make the biggest impact on reliability? If we think about just one thing and we prioritize that one thing, we should be able to roll that in with our current sprint. So what's that one thing? Focus on that, and that's the one thing you do, and you just do it. So what sort of tools do we use? Well, we use a tool called Donut. Donut was actually something that started as a way for folks to just engage, a way to replicate the water cooler effect in an office. In an office, you normally would get up and you'd go get coffee, or you'd get up to get some water or a snack. And this was a fantastic way to get to know your colleagues. In Gremlin's office, we've got plenty of snacks for those that are in our small office. But we realized that most of our staff are remote. 90% of Gremlins are spread out across the US. And so we wanted to replicate that experience that people had, to build that culture and build that camaraderie. So we already had Donut. But one of the other great things about Donut is that it's designed to pair people up, to group people together, to find common experiences. And so with Donut, it works by pinging a bunch of people in Slack and then having them set up a time together. This sounds almost exactly like what we wanted with our mini game days. So we set up Donut. Donut is set to automatically create groups of 3 engineers based on the least participated. So in that way, it ensures that every engineer has an opportunity to do a mini game day. So Donut will automatically group up 3 engineers at a time. It'll check their calendars, and it'll note the blocks of time that all of them are free. All of them are available to run a mini game day. The other really cool thing that it does is Donut will automatically set up a Zoom call for them. So in that way, basically all of your logistics and planning is taken care of. So what other tools are we using? Well, I mentioned that we really want to automate the process of actually running the game day. So I started off really simply, the engineering way, right? Build an MVP, something that does basically what you need to do, and then iterate from there. So I built a Google form, really easy. Google Form has all of the steps that you need to do, but as a form, it provides fields that you just need to enter your answers and fill it out. And once you do that, the reporting becomes automated. We can generate all of the reports directly from that form, saving you time and a lot of the tedious work that all engineers hate to do. Now, as we've gone through this process, as mentioned, you're engineers, you iterate. So some folks have decided to try to use Slite, which is the internal documentation tool that we use. It's a fantastic way to gather notes, but it doesn't quite have that automated reporting. Other engineers have decided to basically run this exactly like you would any other game day where you're practicing your incident response. So along with that, they use our incident response tool. They're running the mini game days directly in Blameless, which is the tool that we use. We'll keep iterating to figure out what the best way to work is and where the best way to capture this information is. But one thing that we definitely want to do is to keep it structured. Well, we like to break it down into really 3 sections. The first is the 5 minutes of planning. As Donut has paired you up, you will join that Zoom call, you'll get acquainted with the folks that you're going to be working with, and you'll decide what sort of test you want to run. Oftentimes this test is whatever was suggested from the previous game day. We try to make this as easy as possible so you don't have to overthink or really spend a lot of time planning what you're going to do. The next 20 minutes is following the game day process. We have people announce that they're going to be running a mini game day. They'll announce this within Slack. They'll let whoever's on call actually know that they're doing this process. And then they'll spend the bulk of their time actually doing the experiment. They'll set the hypothesis, they'll inject the failure, and they'll analyze it. The final section is 5 minutes at the end for reporting. Again, we're using a form, so everything should be highly automated. There's not a whole lot of stuff that they have to do. What they really have to do, though, is decide on that one thing. The one thing that would make the biggest impact on reliability. They'll take that, they'll create a JIRA ticket for it, and that really accomplishes the task. Now, if there's anything else that they've encountered, anything that needs a follow-up, we have a section for that too. So they can enter in that next experiment for the following team to investigate. And this is how we continue to keep improving. Because once that one thing gets done, there's always another thing. So where do we go from here? What's next? Well, I had already mentioned that we've done a lot to iterate, to try to continuously improve the process. That's probably the biggest lesson to learn, is that when you roll this out, it's never going to be perfect. When you roll it out, you will likely face a similar experience to me, that some folks are going to be resistant, that you're going to make some impacts on teams that they won't like. Reliability doesn't come for free. It's an investment. But the great thing is, if you invest in reliability, you get more reliability. So it's worth the investment. But even beyond that, you're going to have to iterate your processes. You're going to have to update what you do and adapt it to your teams. But as you start to adopt chaos engineering, remember that the experimentation isn't the hard part. You likely already know where your systems might be unreliable or might have improvements to be made. The hard part is everything else. So as you roll out your practices, keep 3 things in mind. Keep it short so that it's inexpensive, and then you can build up a practice. Create a process and automate what you can. This makes execution and reporting a whole lot easier. And third, balance your priorities. Don't try to fix everything all at once. There's going to be a lot to do. So focus on the one thing, just one thing that you can do that would make the biggest impact on reliability. Make that the goal of every game day.